Today we are going to go over domain and range. This is probably one of the biggest topics that I have tutored that students just consistently have a hard time understanding. And I'm really hoping that the way that I explain it to you is going to be a game changer for you. So let's go ahead and start by just defining what a domain is and what a range is. So the domain is the set of all x values that a function can accept. So, for instance, let's think of this in a real life example. Okay, we can have two different variables, say a height and a weight and an age. Okay, so for instance, if we were to input an age for a person, then we could get an estimated range of heights that they would be. And there are certain heights that would make sense. For instance, you're not going to have a negative height for that because a person cannot be a negative height. Similarly, you would not have a negative age because they could not be a negative age. So that's an example of what you could use. Now, let's go ahead and define range as well. Similarly, range are all of the y values, all the output values that the function can produce. So in the example that I just gave, the height would be the output. We're going to input the age and we would output some heights that would be appropriate for that. So we're going to talk about this over a couple different functions. We're going to talk about it for linear functions, for rational functions, for square root functions, and also for absolute value functions. Let's go ahead and start with linear. A linear function is a function in the format of y equals mx plus b. In other words, it's just going to be a straight line. Now, what's really happening here is that we are looking for all of the possible x values of this function. Now, we can examine this going, let's just start from the middle and we're going to go left. Okay, this arrow is heading in the northwest direction. Okay, if you were to kind of put this on a compass, we would have like north, east, south, and west. And this arrow is definitely heading in the northwest direction. Because it has a west component and it's going to the left forever, that means that it's approaching negative infinity. Now, as we're going this way, this is southeast. And because there is an east component, it is heading to the right forever, which means that our domain is going to be all real numbers. And the way that we write that is with a D. And I usually do a double backed R, or you can write it this way, where you just write all real numbers, or depending on how your teacher wants you to write it, maybe in interval notation, negative infinity to positive infinity. So I'm going to write the directions up here, NW and SE. Now, when we're talking about domain, we are only talking about the west and the east component because that is the part that falls on our x-axis. So what do you think we're going to do for the range? Well, we're only going to pay attention to the north and south component because that is what the y-axis is. Now, similarly, since the line is going to be increasing this way forever, it has a north component. And since it's going to be also decreasing on the right side, this answer is also going to be all real numbers for the range, or all real numbers or negative infinity to positive infinity. That means that for lines, and it's always this way, by the way, when you have a slanted line, the domain and range will always be all real numbers. Now let's go and talk about a rational function. Now let's talk about a reciprocal function. So here you can see that we have two parts of our graph. We have this part down here and this part right here. Now, You may notice here that there is something called an asymptote right down our y-axis, and that is where the graph actually breaks. So this is not a continuous graph. Well, that's the reason why that is because if we were to plug in a 0 here where the x is, that input, our output would be 1 over 0. And we are never allowed to divide by 0 in math. That creates an asymptote. So, as far as our domain is concerned, we are heading to the left forever. And so that's going to be part of our answer is going to be negative infinity. And we're going all the way over here. We do have, this is heading to the right, but then it stops at 0. So we cannot include 0 in our domain. And then we're going to put it together because after we hop over, after it goes down forever, we have to hop over this line here, and then it starts up here again, okay, infinitely close to 0, and it continues to the right forever. So we're going to put 0 here and then over to positive infinity. So this union here kind of acts like a bridge between the two sets. So what it's saying is that the graph exists everywhere to the left of 0, that's this, and then also everywhere to the right of 0, that's this, but it does not include 0. That's what that middle part means. Now, let's talk about our range. So similarly, our range here across our x-axis is also, let me make that a little thicker here. There we go. Is also undefined there. And so what we're going to have to do here, let me write this down as the domain, for the range is going to be actually exactly the same thing. It's going down forever, which means that negative infinity is a part of our range. Then it goes up and it stops at this 0 line, but then after 0, it continues to go up. So it's actually going to be exactly the same thing. But these are all of the possible y values for the graph. Essentially, what we have to make sure of when we have a rational function is we have to exclude values where the denominator would equal 0. And in this case, that's exactly what we're doing right here. Now let's talk about square root functions. The parent function for a square root function is going to be where y equals the square root of x. So essentially, our graph is going to look something like this. We're going to start out at 0, 0, 1, 1, and then 4, 2 here. It's basically half of a sideways parabola. Okay, so for our domain, we are looking on our x-axis, and we're looking at our endpoints. Okay, our endpoint is actually right here. It is a definitive number, and that number starts at 0. So we are going to have a hard bracket because this includes 0. And the other arrow is heading in the northeast direction. And because it has an east component, it's going to go to infinity. So 0 to infinity. Another way you might see this written is where x has to be greater than 0. That's also sufficient to write. Now, similarly for our y values, we are looking down here. We're going to go all the way up to our endpoint, and we are starting at 0. So our range is also going to start at 0. And because our arrow is heading in the northeast direction and we're focused on the north component, it is also going to be infinity. Or y is greater than 0 here as well. So the key thing to remember here, why is it greater than 0? excuse me, greater than or equal to 0 on both of these. Why is it greater than or equal to 0? It's because we cannot have a negative under the radical. When we have negatives under the radical, we start to get into imaginary numbers, but that won't come until a little bit later. When we are talking about domain and range, we are going to be talking about real numbers here. Now, let's discuss the absolute value function. When we're talking about domain, we have an arrow here that is headed in the northwest direction. And because it has a west direction, it's going to be negative infinity. Similarly, we have a northeast direction over here, so that is going to be positive infinity. Okay, so writing this out, we can write it one of two ways, or one of three ways actually, or just the words all real numbers. Okay, now for range, we can look at our endpoints here. We can see that this is heading in a northern direction on both of these. So we know that positive infinity is going to be one of our endpoints here. But the question is, where does our graph start on our y-axis? So if we start here, boom, it starts right here at 0 and including 0. So we get a hard bracket there. Another way you might see that written is y is greater than or equal to 0. Okay, that means that the domain is all real numbers and the range is y is greater than or equal to 0. So I hope that was helpful for you. Go ahead and click the subscribe button. If you would like some more videos on these topics, I would be happy to cover that, or just ask any questions that you have in the comments and I'll do my best to respond to you. I hope that you have a great day and I hope that this was helpful for you. I will see you next time.